J. Robert Oppenheimer, a brilliant physicist and an enigmatic figure in the history of science, played a pivotal role in the development of the atomic bomb during World War II. His life and career were marked by extraordinary accomplishments in theoretical physics, leadership in the Manhattan Project, and later, controversies and challenges that shaped his legacy. This biographical essay aims to delve deep into the life and contributions of J. Robert Oppenheimer, shedding light on his early years, scientific achievements, leadership in the atomic bomb project, post-war career, and the controversies that surround him. Early life and education. J. Robert Oppenheimer was born on April 22, 1904, in New York City to Julius Oppenheimer, a wealthy textile importer, and Ella Friedman, a painter. His early life was marked by privilege and exposure to a wide range of cultural and intellectual influences. He showed an early aptitude for science and mathematics, which led him to attend the Ethical Culture School in New York City, where he developed a love for literature and languages as well. Oppenheimer's early education laid the foundation for his later academic success. In 1922, he entered Harvard University as an undergraduate, where he excelled in various subjects, particularly physics. He completed his bachelor's degree in 3 years, graduating summa cum laude in 1925. After Harvard, Oppenheimer continued his studies in Europe, where he studied under prominent physicists like Max Born and Wolfgang Pauli. He spent time at the University of Göttingen and the Cavendish Laboratory at the University of Cambridge, where he deepened his knowledge of quantum mechanics and relativity theory. Upon his return to the United States, Oppenheimer pursued his doctoral studies at Harvard, where he worked with the influential physicist Percy Bridgman. In 1927, he completed his PhD thesis on quantum theory, solidifying his reputation as a promising young physicist. This early period of Oppenheimer's life was marked by intellectual curiosity and a rapid rise within the academic world. 2. Scientific achievements. Oppenheimer's scientific career was distinguished by groundbreaking research in theoretical physics, particularly in the fields of quantum mechanics and astrophysics. Some of his notable contributions include the Born-Oppenheimer approximation. In collaboration with Max Born, Oppenheimer developed the Born-Oppenheimer approximation, a fundamental concept in quantum chemistry. This approximation allows for the separation of nuclear and electronic motions in molecular systems, simplifying the mathematical treatment of complex molecular structures. Oppenheimer-Phillips process. In 1935, Oppenheimer and Melba Phillips proposed the Oppenheimer-Phillips process, which explained the mechanism behind nuclear fusion in stars. This process, also known as the proton-proton chain, is central to our understanding of stellar energy production. Neutron stars. Oppenheimer and his student George Volkoff made significant contributions to our understanding of neutron stars, which are the collapsed remnants of massive stars. They developed the first detailed theoretical models of these incredibly dense celestial objects, which have since been validated by observations. Electromagnetic isotope separation. During World War II, Oppenheimer worked on the development of electromagnetic isotope separation techniques, a critical part of the Manhattan Project. This work was instrumental in obtaining enriched uranium for the atomic bomb. Oppenheimer's research contributions were not only significant in their own right, but also reflected his deep understanding of the theoretical foundations of physics. His work in various areas laid the groundwork for subsequent advancements and earned him a reputation as one of the leading theoretical physicists of his time. 3. The Manhattan Project. World War II brought about a dramatic change in J. Robert Oppenheimer's life and career. In 1942, he was appointed as the head of the Los Alamos Laboratory, a top-secret research facility in New Mexico, where he would lead the development of the atomic bomb as part of the Manhattan Project. The decision to entrust Oppenheimer with this responsibility was based on his scientific acumen, leadership qualities, and his strong advocacy for the project. The Manhattan Project was a colossal scientific and engineering effort aimed at creating an atomic bomb before Nazi Germany could. Oppenheimer assembled a team of some of the brightest minds in physics, chemistry, and engineering, including scientists like Enrico Fermi, Richard Feynman, and Hans Bethe. The collaborative and secretive nature of the project was crucial to its success, and Oppenheimer's leadership played a central role in maintaining this environment of innovation and security. Under Oppenheimer's direction, the Los Alamos laboratory developed two distinct approaches to creating an atomic bomb: the uranium-235 gun-type bomb, codenamed Little Boy, and the plutonium implosion-type bomb, codenamed Fat Man. These efforts culminated in the successful testing of the first atomic bomb on July 16, 1945, at the Trinity Test Site in New Mexico. The destructive power of the atomic bomb was unleashed when it was dropped on the Japanese cities of Hiroshima and Nagasaki in August 1945, leading to Japan's surrender and the end of World War II. The Manhattan Project's success and the role Oppenheimer played in it marked a turning point in history, with profound implications for the post-war world. 4. Post-war career. After World War II, Robert Oppenheimer's career took a different trajectory. He continued his involvement in government service and scientific research while also facing new challenges and controversies. Some key aspects of his post-war career include: Director of the Institute for Advanced Study. In 1947, Oppenheimer was appointed as the director of the Institute for Advanced Study in Princeton, New Jersey. In this role, he oversaw a prestigious academic institution that was home to leading scholars in various fields. The AEC and Advocacy for Civilian Control. In 1947, Oppenheimer was appointed as the chairman of the General Advisory Committee of the Atomic Energy Commission, AEC. In this capacity, he advocated for civilian control of atomic energy and the peaceful use of atomic power. His influence in these matters was substantial, and he played a crucial role in shaping post-war nuclear policy. Opposition to the hydrogen bomb. During the early 1950s, Oppenheimer opposed the development of the hydrogen bomb, a significantly more powerful and destructive weapon than the atomic bomb. His stance put him at odds with government officials and other scientists, leading to a contentious and divisive period in his career. Controversies and security clearance revocation. Oppenheimer's opposition to the hydrogen bomb and his association with left-leaning intellectuals during the era of McCarthyism placed him under scrutiny by government officials. The Red Scare and growing anti-communist sentiment in the United States led to allegations of communist sympathies against Oppenheimer. These controversies culminated in the revocation of his security clearance in 1954. The security clearance revocation marked a low point in Oppenheimer's life and career. It effectively ended his official involvement in government service and severely damaged his reputation. The decision was not without controversy, as many prominent scientists, including Albert Einstein, voiced their support for Oppenheimer and criticized the government's actions. Oppenheimer's case raised questions about the balance between national security concerns and academic freedom, and it remains a subject of historical debate and analysis. 6. Legacy and impact. Robert Oppenheimer's legacy is complex and multifaceted. His contributions to science, particularly his leadership in the development of the atomic bomb, significantly impacted world history. The destructive power of the bomb, as well as the subsequent nuclear arms race, raised ethical, moral, and political questions that continue to reverberate today. Despite the controversies and challenges he faced, Oppenheimer remains a revered figure in the scientific community. His brilliance, leadership, and contributions to theoretical physics continue to be studied and celebrated. His ability to bring together diverse minds for a common goal, as seen in the success of the Manhattan Project, is often cited as a testament to his exceptional leadership skills. The lessons learned from Oppenheimer's life and the ethical dilemmas raised by the development and use of the atomic bomb continue to be debated and explored in various academic and public forums. His story serves as a cautionary tale about the ethical responsibilities of scientists in the pursuit of knowledge and the potential consequences of their discoveries on humanity. Robert Oppenheimer's life journey, from a promising young physicist to the leader of the Manhattan Project and later a controversial figure, embodies the complexities of human nature and the pursuit of knowledge. His scientific contributions, leadership, and the moral quandaries he faced during his career make his story a compelling and thought-provoking narrative in the history of science and the modern world. The impact of the atomic bomb and Oppenheimer's central role in its development forever altered the course of history, underscoring the importance of ethical considerations in scientific advancements. His life and work continued to be studied, debated, and remembered, leaving an indelible mark on the scientific community and society at large. The story of J. Robert Oppenheimer remains a testament to the dual nature of scientific progress, a force that can both shape the world and challenge the ethical boundaries of humanity.